Hello everyone, welcome to our channel. Last class we have discussed about sets. The chapter is completed. Now I am going to start third chapter in our 10th class textbook, that is polynomials. Polynomials. So before going to polynomials, we are discussing with the examples. For example, in our school garden, the length of the garden, the school garden is in rectangular shape. The length of the garden is 100 meters and the breadth of the garden is 50 meters. Length of the garden is 100 meters and the breadth of the garden is 50 meters. Okay, now previously how we should find the area of the rectangular garden? Area of rectangular garden. What is area of rectangle? In previous classes we have learned area of rectangle. What is the area of rectangle formula? Area of rectangle implies A equal to L into B. A equal to L into B, that implies A equal to 100 into 50. A equal to 100 into 50, so that implies area equal to 5000 square meters. Area always in square meters. Here meter and meter. Meter into meter, square meters. Like that we have learned in previous classes. But coming to our polynomials chapter, how we can say this statement? For example, in our school garden, the breadth of the garden is twice of its breadth. Twice of its breadth. So let the length of the garden is, actually garden is in rectangular shape. But here given the condition is the length of the garden is twice of its breadth. Twice of its breadth. Actually here we don't know what is length of the garden and what is the breadth of the garden. But here given the condition, what is the given condition here? The length of the garden is twice of its breadth. Twice of its breadth. On that time we are taking breadth. Let breadth implies B is equal to X meters. B equal to X meters. Here given values 100 meters and 50 meters. According to the given values, we have to find the area of rectangle. But here not given values, but here given condition. According to the given condition, we have to follow. Means here let breadth of the rectangle, breadth of the park equal to X meters. Here according to the given condition, the length is twice of its breadth. So what is the length? Length implies L is equal to twice of its breadth. Breadth is equal to what? X. So now length and breadth. Now what is the area of rectangle here? X, 2x into x, that is equal to 2x square meters. Here we are using direct values. But here we are using variables. So in which the statement we are using variables, that is called algebraic expressions. Algebraic expression. For example, x is a variable here. Here 2x also, in 2x also we are using variables. 2x square, in 2x square also we are using variable. Here in these three statements, x is a variable. So x is algebraic expression. And 2x also algebraic expression and 2x square also one of the algebraic expression. So finally we conclude that what is mean by polynomial? What is mean by polynomial and how to identify which are polynomial and which are not a polynomial. Which is polynomial and which is not a polynomial. So here and find out the difference between algebraic expression and the polynomial. Algebraic expression and polynomial. So first of all, what is algebraic expression? Algebraic expression. Just now I said here 100 is a value and 50 is a value. For example, the value is multiplied with the any variable. The value is multiplied with the any variable. That is equal to, simply we can write as 2x. 2x is algebraic expression. And one more. For example, the value 4 is multiplied with any variable p and add to 5 and add with 5. So that is equal to 4p plus 5. Also one of the algebraic expression. 2x is algebraic expression in variable x. 4p plus 5 is algebraic expression in variable p. But then what is the difference between these two? Here we are not using constant term. Here in this algebraic expression the constant term is 0. In this algebraic expression the constant term is 5. Now according to these two terms we have to know that what is mean by algebraic expression. Algebraic expression means an expression which involves the variable. P is a variable here. Variable coefficients. Coefficient means previous of the variable is called coefficient. 4 is in this expression, in this algebraic expression, 4 is coefficient of p. 4 is coefficient of p. So an expression which involves the variable, coefficients and the constant term along with operation, any operation either plus or minus along with operation is called algebraic expression. Is called algebraic expression. For example, 4x plus 3y. 4x plus 3y is algebraic expression or not? Yes. 4x plus 3y is also algebraic expression. Here in variable x and y. In this algebraic expression we are using two variables, x and y. Here 4 is coefficient of x and 3 is coefficient of y. 3 is coefficient of y. So we conclude that finally what is mean by algebraic expression? An expression which involves the variable, coefficient and constant along with operation is called algebraic expression. For example, if constant term is 0, here 2x, there is no constant term here. It means what? The constant term should be a 0. So here 2x also one of the algebraic expression, 4p plus 5 also an algebraic expression, and 4x plus 3y also algebraic expression. Okay now how to identify which is polynomial and which is not a polynomial? Which is polynomial and which is not a polynomial? For example, 4x plus 5. 4x plus 5 is a polynomial. 4x plus 5 is a polynomial. Here 2x, 4x plus 5, x plus 1 by 5, x square plus 2x plus 5. 4x power 1 by 2, 3x square plus 4x power minus 1 plus 5 and 1 by x plus 5. 1 by x plus 5. Just we can observe that which is a polynomial and which is not a polynomial. Here 2x, these all are algebraic expression, we know. These all are algebraic expression, but these all are polynomials, these all are not a polynomial, but these all are algebraic expression. So here 2x, here the power of x is 1. So this is non-integral power. Non-integral power means 1 is not a negative term. The power is not a negative. Next 4x plus 5. If this here also the power of variable is positive. Here also polynomial x plus 1 by 5. Here only the constant term is in a fraction. The power of the variable also here 1. So it is a polynomial. Here x square plus 2x plus 5. Here x power is 2. Here x power 1 and the constant term is 5. So these all are polynomials. And how to identify which is polynomial and which is not polynomial? So here the power of the x is equal to 1. This is non-negative integral power. Non-negative integral power. But here the power is in fraction. X power 1 by 2. Simply we can write as 4 root x. 4 root x. This is not a polynomial. If the power is integral power, this is not a polynomial. And 3x square plus 4x power minus 1 plus 5. Here also power negative power. If the variable has negative power, that is not a polynomial. And 1 by x plus 5. Here the variable is in denominator. It means x power minus 1. Yes or no? 1 by x means what? X power minus 1 plus 5. This one also not a polynomial. Now what is mean by polynomial? An algebraic expression which has non-negative integral power of the variable. An algebraic expression which has non-negative integral power of the variable is called a polynomial. Variable has non-integral power. Non-integral power means the power is positive. Like that we have to identify which is polynomial and which is not a polynomial. Now one more question just now I raised. What is the difference between algebraic expression and the polynomial? Algebraic expression and the polynomial. Here there is no condition of algebraic expression. Either power is negative or positive or in fraction or not in fraction, not a problem for algebraic expression. These all are algebraic expressions. These all are algebraic expression. But for the polynomial we have some condition, we have some rules. Here not integral power and the variable is not in denominator. Like that we have some rules. If here for example 3x square plus 4x power minus 1 plus 5. Here the power is not a integral power. This is not a integral, non-integral power. This is a integral power. Integral power means power is in negative. So minus 1. So this is not a polynomial but algebraic expression. So finally we conclude that the relationship between algebraic expression and the polynomial is all the polynomials are algebraic expressions, but all algebraic expressions are not a polynomial. All algebraic expressions are not a polynomial, but all the polynomials are algebraic expressions. That is the difference between polynomial and algebraic expression. Like that we have to identify which is polynomial and which is not a polynomial. Next topic, degree of polynomial. So what is mean by degree? The highest in the terms of polynomial, the highest power of the variable is called degree. Is called the degree of the polynomial. Degree of polynomial. I am giving with example. See here, for example, 2x square plus 5x plus 9. 2x square plus 5x plus 9. Here we are taking the highest powers. Here how many terms are there in the polynomial here? First we are going to check it is a polynomial or not. It is a polynomial. Why? Because it is in the form of ax square plus bx plus c. Means this is not a integral power. This is non-integral power. Non-integral power means the power is positive. The power is positive and variable not in denominator. All are numerators only. Okay, so it is a polynomial. Now we are going to check. Just now I said what is the definition of degree of a polynomial. In the separate terms, here how many terms are there? 3 terms are there. 2x square is one term and 5x is one term and 9 is another term. Okay, now so here 2 is coefficient of x square, 5 is coefficient of x and 9 is constant term. 9 is constant term. So here how we can identify the degree of polynomial? Degree of polynomial. So what is the degree? Highest power of the variable is called degree. Here which is the highest power? In this term the power of the x, the power of the variable is 2. In this term the power of the variable is 1. Here there is no variable. So this is a constant term. So now what is the highest power of the variable? The highest power of the variable is 2. So the degree of the given polynomial is 2. Here what is the degree? Degree is equal to 2. Degree is equal to 2. Now we are saying that here just we can observe that all the terms, all the separate terms, which variable has the highest power. The highest power of the variable is called degree. Here 2 is the highest power of the variable, that is the variable x. So 2 is the degree of the given polynomial. 2 is the highest power. So the degree of this polynomial is 2. Clear? Okay. For example, here given, sometimes they are given polynomials in 2 variables. In 2 variables like 2x square y square plus 5xy plus 7. 2x square plus 5xy plus 7. Okay, here this is also polynomial and algebraic expression also. This is a polynomial in 2 variables x and y. In 2 variables x and y. For example, if they are given 2 variables, in one term, how we can identify the degree of polynomial. How we can identify the degree of polynomial. First we have to dividing the terms. This is 2x square y square is one term. 5xy is also another term. Here 7 is a constant term. So here we are using x and y variables. The power x power is 1 and the y power is 1 in this term. In this term the x power is 2 and the y power is 2. If in one term the powers are different, the powers of the different types of variables. Here x power is 2 and y power is 2. On that time the degree is addition of the power of the variables. Addition of the power of the variables. Highest addition of the highest power of the variables. Means here the x power is 2 here. In this one term only the x power is 2 and the y power is 2. So here what is the degree of this term? 4. Here what is the degree of this term? Here x power 1 and y power 1. So the degree is 2 here for this term. And this is a constant term. Now we can identify which is the highest power, highest sum of the powers. Here sum of the powers is 4 here. So the degree of the polynomial, the given polynomial is 4. If they are given different variables, we should add the powers of the variable in a particular term, not others, in a particular term. This is total one term only. Okay, don't add 2 plus 2 plus 1 plus 1. Only one term. We should add the powers of the different variables. So which is the highest power of the variable, sum of the powers of the variable, that is called degree. That is called degree for different variables. Now according to the condition, the degree of this polynomial is 4. The degree of the polynomial is 4. So we have to comparing 4 is greater or 2 is greater. Here 4 is greater, so the highest power is 4 here. So the degree of the 2x square plus y square plus 5xy plus 7 is 4. This is the degree. Like that we have to identify the degree of polynomial. Next, general form of polynomial with the degree n. So nth degree polynomial, what is the general form of polynomial with the degree n? How we can write? This is p of x equal to a0 x power n. a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on. Finally a n minus 1 x power 1 plus a n x power 0 here. A n x power 0. This is the general form of polynomial with the degree n. Why degree n here? In this term, all the terms we have to check it once. Here the degree of the variable is n. The degree of the variable is n minus 1. The degree of the variable is n minus 2, like that going on decreasing. Here not increasing the powers of the variable. Here the powers of the variables are decreasing. Already we know what is the degree. Highest power of the variable is called degree in the separate terms. Here a0 x power n. This is only highest power. So what is the degree here? N. The degree of this polynomial is n. So then what is the general form of polynomial with the degree n? P of x equal to a0 x n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on a n minus 1 x1 plus a n x power 0. So here x power 0 value 1. So finally this is a n. This is a n. Here a0, a1, a2, a n minus 1 and a n. These all are coefficients. If all are this a1, a0, a1, a2, a n minus 1, a n all are 0, for example, if this all the coefficients are 0, this is called zero polynomial. Finally we conclude that if a0, a1, a2, a3, a4 like that up to an, this all the coefficients are 0, then what is p of x here? Then p of x is equal to 0. If we got the value of the polynomial is 0, that is called zero polynomial. This is zero polynomial. zero polynomial. Then why zero polynomial? What is the condition? If all the coefficients are equal to 0, then only the given polynomial is zero polynomial. Otherwise, this is a general form of polynomial with a degree n. Why degree n? This is the highest power of the variable is called degree. The degree is here what? N. Clear? Okay. Next, types of polynomials: linear polynomial, quadratic polynomial, and the cubic polynomial. So here the general form of linear polynomial is ax plus b. The general form of linear polynomial is ax plus b. The general form of quadratic polynomial is ax square plus bx plus c. Ax square plus bx plus c. Next, the general form of cubic polynomial is ax cube plus bx square plus cx plus d. Cx plus d. Okay now, so here what is the general form of linear polynomial? Ax plus b. The general form of quadratic polynomial ax square plus bx plus c. The general form of cubic polynomial is ax cube plus bx square plus cx plus d. So now, what is the degree of linear polynomial? The degree of linear polynomial is 1. Why? Because in that linear polynomial, the highest power of the variable is 1. The highest power of the variable is 1. That's why it has only 1 0. It has only 1 0. That 0 is if ax plus b equal to 0, then ax is equal to, by using transposing method, plus b is sent to right side, it becomes minus b, then x is equal to minus b by a. X is equal to minus b by a. This is the 0 of the linear polynomial. 0 of linear polynomial, x is equal to minus b by a. When we are doing graphical representation, the point touches in this linear polynomial when we are doing the graphical representation. So this touches the x-axis on minus b by a comma 0. Touches on minus b by a comma 0. Why? Because here y-axis should be 0 and x value is equal to minus b by a. Minus b by a comma 0. Okay, I will give one example. I am explain with example. For example, 4x plus 5 equal to 0. 4x plus 5 equal to 0. This is a linear polynomial. How we can identify the given polynomial is linear polynomial? Once we check it, highest power of the variable is called degree. What is the degree of this polynomial? 1. So it is a linear polynomial. Linear polynomial has how many zeros? Linear polynomial has how many zeros? Only 1 0. According to the degree, we have the zeros. Here degree is 1. So that's why the linear polynomial has only 1 0. But how we can identify, how we can find the 0 of the linear polynomial? Once you see here, 4x equal to, if plus 5 is sent to right side, minus 5, then x is equal to minus 5 by 4. So just now I said minus b by a. The value of the x is equal to minus b by a. Now here what is the value of b and what is the value of a? B is in linear polynomial. In linear polynomial, 4 is, this is ax plus b form now. The coefficient of x is equal to a and the b is constant term. So here in this polynomial, what is the value of a? 4. What is the value of b? 5. What is the formula? Minus b by a. Just now I said minus b by a. X is equal to minus b by a. So that is equal to minus 5 by 4. Like that also we are going to find. Understand? What is the 0 of linear polynomial? X is equal to minus b by a. So touches x-axis. Touches x-axis, what is the point touches on x-axis? That is minus x comma 0, that is minus 5 by 4 comma 0. Minus 5 by 4 comma 0. Clear? Now, coming to quadratic polynomial. coming to quadratic polynomial. So what is the general form of quadratic polynomial? Ax square plus bx plus c. Here what is a? Coefficient of x square is a, coefficient of x is b, c is a constant term. C is a constant term. So here what is the degree of quadratic polynomial? What is the highest power of the variable here? The highest power of the variable is 2. The highest power of the variable is 2. So it has, the quadratic polynomial has 2 zeros. 2 zeros. Then how we can find the 2 zeros? By using by using factorization method. Sorry, by using factorization method we have to find 2 zeros. We have to find 2 zeros. Okay now. So here cubic polynomial. Next. Cubic polynomial. Here what is the general form of cubic polynomial? Ax cube plus bx square plus cx plus d. Ax cube plus bx square plus cx plus d. Here the highest power of the variable is 3. So it has how many zeros? 3 zeros. 3 zeros. It has how many zeros? 3 zeros. Okay now. The next topic is value of polynomial. What is value of a polynomial? I am going to explain with example. Okay now. So for example, p of x equal to x square minus 2x minus 3. If we are taking x is equal to 1 here, if we are taking the value of x is equal to 1, instead of x we are taking 1. So what is the value of p of 1? P of 1 is equal to 1 square minus 2 of 1 minus 3. Okay. Instead of x we are substituting the value 1. Here x square means 1 square minus 2 into x, 2 into 1 minus 3. Now 1 square value 1 minus 2 ones are 2 minus 3. So that is equal to 1, both negative terms. 2 has negative symbol and 3 has negative symbol. Both numbers having negative, we should add with a negative symbol. We should add, and finally we write a negative symbol. So 2 plus 3, 5. So that is equal to 1 minus 5 minus 4. 1 minus 5 equal to minus 4. So here what is meant by value of polynomial? So minus 4 is value of polynomial p of x equal to x square minus 2x minus 3 at x is equal to 1. At x is equal to, we will get another value. At x is equal to 3 we will get another value. X is equal to 4 we will get another value. So finally we conclude that what is the value of polynomial? Here minus 4 is value of polynomial p of x equal to x square minus 2x minus 3 at x is equal to 1. That is important. At x is equal to 1. At x is equal to 2 we will get another value. At x is equal to 3 we will get another value. That is value. Here in if x, where x is equal to 1, the value of p of x is equal to minus 4. For example, if you are taking in the place of x 4, now what is p of 4? P of 4 is equal to 4 square minus 2 of 4 minus 3. So that is equal to 4 square value 16 minus 2 for the 8 minus 3. That implies 16 minus 8. 16 minus 8 minus 3 minus 11. That is equal to 5. Here what is the 5? 5 is the value of polynomial p of x equal to x square minus 2x minus 3 at x is equal to 4. Here at x is equal to 1 what is the value? Minus 4. At x is equal to 4 what is the value? 5 of the polynomial p of x square minus 2x minus 3. The polynomial is same here. Values will be changed according to the values of x. As per the values of x. This is the values of polynomial. Value of polynomial. The next topic is 0 of polynomial. Same example we are taking. P of x is equal to x square minus 2x plus 3. P of x is equal to x square minus 2x plus 3. Just now we have substituted in the place of x1 and in the place of x4. Once we substitute in the place of x2. If x is equal to 2, then p of 2 is equal to 2 square minus 2 of 2 plus 3. So that is equal to 4 minus 4 plus 3. So finally we got the value 3 here. We got the value of 3. So 3 is the value of polynomial p of x equal to x square minus 2x plus 3 at x is equal to 2. For example, in the place of p of 2, the value we got, the value is 0. If for example, instead of x we substitute 2, the value is, if we got a 0, the p of x is 0 of polynomial. For example, once we substitute 3, if x is equal to 3, then p of 3 equal to 3 square minus 2 of 3 plus 3. 2 of 3 plus 3. So that is equal to 9 minus 6 plus 3. 9 minus 6 plus 3. So better we can take minus here. Okay now, so x square minus 2x minus 3, then p of x is equal to x square minus 2x minus 3. Then if x is equal to 3, then p of 3 equal to 3 square minus 2 of 3 minus 3. 3 square value 9 minus 2 3s are 6 minus 3, that is equal to 9 minus 6 minus 3 minus 9. The value is 0. If we got the value is 0, then it is a 0 of polynomial of p of x square minus 2x minus 3. X square minus 2x minus 3. If we got the value is 0, it means 0 of the polynomial. If we got the value something, means 3. 3 is the value of polynomial p of x at x is equal to 2. Here this is a 0 of polynomial of p of x is equal to x square minus 2x minus 3 at x is equal to 3. At x is equal to 3, p of x is a 0 of polynomial. At x is equal to 3, p of x is 0 of polynomial. That is the difference between value of polynomial and the 0 of polynomial. Okay, thank you.